I already started a little bit speaking, but nothing interesting yet. So I will start with the presentation. Let me see if I can still admit people. So now you should actually see the presentation and not my Microsoft Teams. Okay. Okay, so I will start from the presentation. Um, I won't be able right now to admit other people, but after the presentation I will. Okay, so as I was saying, Arnali and I are working for the UNGSC, which is the logistic base of the UN. There are basically two offices, one in southern Italy, in Brindisi, and another one in Spain, in Valencia. So those two offices are basically doing all the supply chain and management for the UN peacekeeping mission and special political missions. So we are working mainly with transportation and logistics. We are storing containers, vehicles, food, medicinals, everything that has to be shipped to the peacekeeping missions all over the world. And we do have also services for geospatial information and telecommunication technologies. So this is what we are mainly doing. We are providing geospatial support to the missions. And then we do have also like we host the trainings and conferences for uniform personnel and also politicians, but as well as UN data management staff. The clients of UNGC, I mean, the entities that we are supporting are all the peacekeeping missions. There are many of them in Africa, but there are some also in Europe and in South America, but also in Asia. Um, and let me just admit some other people. Okay, we are up to 40 people right now. So one issue that we had in the past with the production of geospatial data was to create. I mean, we were creating data on private databases, and this data won't. It was difficult to manage and to update because basically what we were doing was to create a lot of data and hiring paid consultants to draw these military topographic maps. That is our main product, and the data wasn't easy to redraw from scratch. So we had to find a solution to spend less money in let's say, in drawing all this data, because especially in many areas in Africa, but also in Asia, like especially in rural areas, the maps are changing continuously. You see new streets, new villages, new waterways, for example, in dry and rainy seasons. So we had to switch to OpenStreetMap. So we switched to OpenStreetMap because the open data is really what allows us to first of all cut costs in producing geospatial data, but also we have the possibility to maintain the data and to really collaborate with many other entities without the need of signing bureaucratic documents or stuff like this. So it's really important to use OpenStreetMap as a base map layer for the information. So this is why also the UN is using it for the even for applications like the topographic map production. So so basically we have many challenges when producing cartographic products for the UN. The first one is the lack of data. So you see here we have a village. This is an actual village in Somalia called Wanlawayn, and in Google Maps you see that there is no houses, no residential areas, no roads. It doesn't exist basically. because like commercial providers, as you know, are providing data only in areas in which they have economic interest. Then we have a lack of operational data. This is specific for the let's say security checkpoints, position of the troops, personnel, and so on. This data cannot be published on OpenStreetMap. We have to keep it private. So that's why we are using like a hybrid approach. We have some data that is not being released, and other data like in OSM that we are editing and contributing to, so that that is available to everybody. The rule of thumb is basically that we are editing all the data that you can view from satellite imagery, or that a person from outside can see. Let's say from outside a UN camp, they can see the data, so we can map this publicly available information. And then we do have with the UN also another challenge, that is the authoritative boundaries. So as the UN, we need to use only authoritative boundaries. So we source this information specifically from the headquarters. So we do have the shapefile for the, let's say, for the international boundaries, but we cannot take them from OSM. And the same for the authoritative geographical names, so the spelling of cities and villages. So that's why we created the UN Maps. UN Maps is a program to produce geospatial information in OpenStreetMap as a base map layer information, on top of which we overlay UN authoritative information for the production of applications for the peacekeeping missions. So we do have like several services, like you can imagine it as a Google Maps, but for the UN personnel. That is not, this application is not indeed available for everybody, but only for UN personnel. But I wanted just to go through very quickly on the topographic maps that we produce. So we do have like a web application in which even non-GIS personnel can just log in and select their area. They need to print PDF maps, so military topographic maps. And you see, those are the maps that we are producing. And in these maps, you can see OpenStreetMap data. So the rendering is not the same, of course, but this data is everything that volunteers like you, like me, people that are contributing to OpenStreetMap is producing. And on top of it, there is UN information. So for those sensible categories of data that we need to add, we just keep it private. The same with other cartographic products like urban maps and site maps. And also, we can leverage both the open data and proprietary data for the routing, for example. So in this case, we do have roadbook products in which we are using, let's say, routing algorithms by using open data for wherever we don't know the road that has to be taken. And then we do have also proprietary data. So we take, for example, supply routes that are patrolled by the UN by the UN troops. So we know that those roads are secure. So we can use OSM data until we don't reach the closest supply route, and then we can use that one to reach the camp. So that is an application for, let's say, routing using an hybrid approach, both OSM and private data. So as I was saying, the data that we are using is mainly used in patrolling, planning, humanitarian relief, logistics, reporting, security, and groundwater exploration. And we established a community of volunteers called the UN Mappers that is involving people from the GIS community in the UN, but also local communities, uniform personnel, academic staff, and students, also national cartographic agencies, and we do capacity building with remote volunteers. So it's a pleasure to have you here in this training. So the way we work is, as many other humanitarian organizations do, is to access the hot tasking manager. We produce the data on OSM. Then internally, we do have like a team of internal consultants that are mapping and validating the data so that we can enhance the different UN map services and then release let's say the data that has been reviewed and quality checked can be benefited from also by the local communities, so they can take advantage of the best of the data. And in turn, the local communities are helping us crowdsourcing more data. So this is like a mutual benefit. Okay, I just don't want to go too long with this presentation. I will just show you the social media. So we are on all social media, so you can find us there. The idea is that we are going to collaborate these weeks to produce data for this project in FAO. Um, and uh, um, the idea is that also we could collaborate to produce the data to have like social media posts together. So you will see uh, you can check our social media handles on. We are basically everywhere: LinkedIn, Facebook, Twitter, um, Mastodon, and so on. And also, I wanted to speak about our website that is maps.un.org. Within this website, you can also access the Learning Hub, that is our learning platform. So we do have a lot of useful material within the platform to learn OSM from the basics to the advanced features on OSM, but also we have a training on QGIS. So that is probably a useful resource for you. So I found a way to admit people as I was speaking, so I can see we are now 60 participants. Um, so that is pretty nice to see. Will the recording be available on YouTube? The answer is yes. I believe yes. Arnaldi can tell us more later on, but we can make the recording available to you. I think yes, in YouTube, either publicly or privately to only NGEs. Okay, I'm going to just to write on the chat the websites that I showed. So maps.un.org/learning. And that's basically it. And then for the social media, you can find them in the website. Regarding the project that we are mapping today, I'm going to share with you the tasking manager project. So I was speaking before. I was speaking before. Oh, sorry. Sorry if I get like some interruptions, but I'm meeting people in the meanwhile, so I'm getting a lot of notifications. Uh, Okay, so I was speaking before with Gorak, and basically he told me that many of you are already knowledgeable with OpenStreetMap, so I can start by just showing the project. So let me see if I can now show my browser in some way. Yes. Okay, so you should see my browser. So I will just log in to my Oof, which account? I guess this one. To my account on the tasking manager, and I will share with you also the project that we are going to contribute to, which is this one. I'm going to share the link in the chat. So this is the project we are going to use. And as I was saying, the purpose of this meeting will be to learn how to map agricultural waterways. I can see some mappers already are working there. That is great. Okay, so from this page we can see the project description. So just for your for your information, this is a project in collaboration with the Food and Agriculture Organization of the United Nations, and they are doing some mapping of agricultural waterways in southern Mauritania. Actually, we already covered all the border between Senegal and Mauritania. We are in West Africa here. Um, and there were like four projects. This is the fourth project, so the last one. So once we are going to finish this one, we will be successful in our mapping because we will have produced all the agricultural waterways within this border. So um, one thing that we do once we enter a project is to click contribute so that we can see the instructions. So here you will have a page with detailed instructions about the editing that we are going to do. So like some recommendations about the imagery and also please do not over extract. So there are some warnings basically. And then we have the tags that we are going to use. So waterways for lines, and then polygons, we are going to use land use equal to farmland. So I will show you right now how, so that maybe with clear examples, it's clearer and more interesting. So I can just start my editing session. I will click on ID editor because I'm using, for this training, I will be using ID editor, but you can also use JOSM if you are more knowledgeable with that one. And then I click map selected task. So this is the first thing that I do when I start mapping. Anyway, if something is not clear, please feel free to write in the chat any question, and I will answer once I get to see it. So, sorry, just admitting people. We are around 62 people right now. Okay, so once I start one task, I can see the situation on the ground. So you see, like we do have here. So basically, okay, let me just explain a bit the topography here of the territory. So the border between Mauritania, that is on the north, and Senegal, that is on the south, is a river called the Senegal River. And you can see it's this big riverbed down here. Um, you can see the color of the water is like not very clean, so it's like a yellow stripe, and that is what we would map as a river if it is not by the fact that it is already mapped, so we don't have to map it anymore. But this is just to give you an idea of the situation. So usually from the river that is mapped with the tag waterway equal to river. So if we zoom in a little bit on the data, we can click on it and we can see that the feature type is river. And specifically, if we are going to the tags down below, we will see that the tag is waterway equal to river. So that is the way to tag a river. So there are plenty of types of agricultural waterways in that we can map in OSM. And I will make a distinction between natural waterways and human-made waterways. So for natural waterways, I mean basically rivers. So you can see this is the first one, that is a river. And then we do have also streams. Streams are basically like rivers, so they are natural waterways, but instead those waterways are much smaller. So you can see if we can go on, we can click on map data at the right. So if we click here, we can deactivate and activate the data just to see better the imagery. So you can see that here actually we don't have any water. So we only see the trace. You see like this groundwater, I mean ground colored area. That is this stripe that is passing through some agricultural farmland. So you see this is like a farmland because we can see um, the crop grid. So we can see like very regular shapes that this area is indeed cropped. And we can see that this stream is going to connect to the river or the canal. So that is the definition of a stream. Obviously, we cannot see the water right here. We can only see some darker ground areas here because this stream is intermittent. That means that the stream is having water only during the rainy season and not only during not every time in the year. So there is in Africa in most places there are basically two seasons, the dry season and the rainy season. So the dry season is usually around summer, so from June to August, and there is or even later, even until September. And the rainy season is basically, I mean, every time is raining. There are a lot of rains, and the vegetation and the water are blooming up. So we have plenty of rivers that are visible. While the dry season, that is the rest of the year, we will have ground areas, and you can see like a darker ground where the areas are more wet. So we can basically spot some water areas just by looking at the color of the ground. Anyway, that is a stream. So the stream is basically like a river, but is it's a natural waterway that is much smaller in width with respect to the river. So if we see the river, the Senegal River here, the width is around I would say 200 meters. If we check the scale down below, will be 200 meters width, while the stream is well, on the Wikipedia of OpenStreetMap, the stream is defined as any waterway that you can basically jump off. So if you are a human and you want to jump from one side to the other side of the waterway and you are able to do it, that is a stream. Just to say that is like a much narrower waterway. So those are basically the two types of natural waterways. We'll just admit some other people, so we are now 56. So these are the natural waterways. So those are waterways that are not built by humans. And how we can recognize natural waterways is basically because of the shape of the waterway. So you see, these shapes are like going not in a straight line. So there are many curves going here and there. So that means that are basically digged by the water naturally. So that is natural waterways. Also the stream here. While if we see a canal or a drain. That is the two tags that we are going to map for human-made waterways. Those have much more straight lines. So you see here, these you see these straight lines are made by humans because they are very straight, as we can see, and they are passing through this farmland in this example. So these waterways are created by humans. So we will be classifying them with artificial waterways. Okay, so um, just let me check if I can get a canal so that I can show you how to map that particular feature. Okay, this one is perfect. Okay, so you see there is a very straight line here, which has also a big width. So that is a canal. So for human-made waterways, we basically have two types of tags that we are going to use. The first one is the canal. So the way we create the canal is to tag to map as a line, and we usually attach it to the river. So if we have a polygon for the river Senegal, we can attach the first node of the canal there, and then um, we can map all the waterway. We have to be sure not to attach the nodes to the highways. So it's very important to keep the features separate so that we don't make a mess with the data. And the way I'm tracing the line is as usual to place the nodes, and then I double click to close the line in this case. So you see, we have many tags here, but this one will be a canal. So the canal is the biggest, I mean, the artificial waterway that has the larger width. So that is like a main connector between the river and the farmlands. So it's bringing a lot of water within the farmlands. So the way I'm tracing it is from the river until the farmland, so that we can see the flow of water. Um, in this particular project, it is not very important to map the direction correctly because here water is going out and exiting. I mean, it's going to the river or entering from the river depending on the season. I mean, when it's like rainy season, most probably the water is flowing out of the ground to the river, and the other way around in dry season. So you can map as you wish. I typically map them from the river to the farmlands. And I can click on canal. So this will be a canal. And you see, I have an issue here because the canal is crossing a road. So it's very good not to attach any node of the waterway to the highway, but I have still to create something that will allow me to say that these two features are not intersecting, right? So you see, we have an option here, add a culvert. So if I click this, you see that my canal will be divided. It was before one line. It will be divided in three lines. So the first line is the canal. Uh, sorry, uh, wait a second. I received like a postman. Sorry. Okay, here I am. Sorry. Um, okay. So I was saying we have here now three lines. The first one is the canal connecting from the river to the road. Then if we zoom in, we do have another line. This line is still a canal, but you see that we have additional tags that is layer equal to -1. That is basically saying that this waterways is below the road. And then we have a tag tunnel equal to culvert. So this means that there is a tunnel digged into the ground that is passing below the road. So this is the way in which we are mapping waterways that are crossing roads without making a mess with the routing algorithms. And then we do have also another canal here on the left. So this one is made by is still coming from the previous geometry, and now we have three geometries. So whenever we have a part that is intersecting a road, this one has to pass below the road, and we are mapping it like this. So layer -1, and then culvert. So this is three lines. And in ID editor, it's much easier to map them because you just click add culvert, and the editor will do the job for you. Anyway, this is the first type of artificial, let's say, man-made agricultural waterway. Then we do have also drains. So to map a drain, we usually connect. So in this case, we can attach nodes because we are mapping basically the same feature. We attach a node from the canal, and then we can map it from the canal to the farmlands. We can recognize farmlands, as I said, as we can see the crop within the farmland. So we can see all these trees in a regular shape. And we will map the drain. So the drain is basically the same as the canal, but it is much narrower, so it's bringing less water. Usually the canal, I mean, from my experience in this project, it seems that the canals are only those connecting the river I mean, connecting the river for the first time with the farmland areas. And then from there, later on, they are all drains. So you can map these drains in this way. Let me just accept other people joining. Okay, and check the chat. Okay, so I hope this was clear. So these are the four types of waterway tags that we are using. We have the river. So this is the Senegal River. That has a width of around 100, 200 meters. Then we have among natural waterways also streams that are like river, but you basically can jump from one side to the other. So, for example, this intermittent stream. Then the other two tags for waterways that are man-made are canal, as you can see here, and drains. Whenever a canal or like any other waterway is passing below a road, we are adding the tag tunnel equal to culvert and layer equal to -1. So to say that this segment is passing below the road. So that, for example, if we do have a routing algorithm like whatever we are using on our smartphone applications using OSM data, it won't cause any error because usually when we are when we are setting to go from one place to the other, and there is a waterway crossing the road, that will throw an error in the routing proposal. So that allows us to just say, okay, this road doesn't have any problem, so we can go from one side to the other side safely. So this was about the waterways. I hope everything was clear so far, and I can switch later on to the farmlands. So just as I mapped, well, we should focus on mapping in our pink boxes here, but just as I mapped a little bit, I will just save the chain set. So I just put within the Tasking Manager project all the hashtags that we need. I also included NGs so that you can track your statistics. So I upload the changes to OSM, and I can come back to map my area now that I explained a little bit the tags that we are going to use. Okay, we can see here we are not on the river, but instead we see the river here on the west. And then moving to the center and to the east, we can see a wetland. So this is a wetland because I can see the ground is a bit darker than the usual. So I can understand that this ground is wet. And also I can see many farmlands all over this wetland. And that's basically because people are using wetland areas to build farmland areas. So they are basically just cropping the area because the ground is already fertile. So they can have farmlands all over here. So this is mapped actually as a lake, which is yeah. mm, I would say it's more like a wetland. So I can just change here. Okay, you are not supposed to map wetlands. Uh, anyway, I will just show you how to map the farmland. So you can see here we do have a farmland. Mm, and also we do have some, I suppose those are streams. Exactly, like because you see those are naturally digged within the wetland, so they have this natural shape and flowing wherever they can. So I can see one of these streams is not finished, so we'll just continue mapping from that point. So I'm always connecting rivers and streams and canals and other waterways to each other so that the waterway network is topologically correct. And here I can assign the tag. So in this case, it's a stream and it's not intermittent because we can see the water also in a dry season. So we established that we are in a dry season in this imagery, so that is fine. Anyway, I can see an error here. A stream flows away from a connected waterway. That is because water has to flow always in the same direction. So you see in this point, this waterway is flowing to the west, and this one is flowing to the east. So we'll click reverse this feature. So the feature is now correct. And then I will map also the missing streams here, stream, and also here to the lake, to this small lake that we have here. It's not important to map everything, so we just finish a little bit after the my ping box so that other mappers can download the data that I traced. And that's it. So now the question will be how to map farmlands, and is that's actually very easy to do. But I need to understand here because we do have a wetland. So people are mapping. I mean, this is a multi-polygon relation. and it's a bit complicated to deal with in ID editor, unfortunately. And just for the time being, I will just modify a little bit the polygon. So we'll just here I'm just putting the polygon only where there is actual wetland. So I'm clicking on the nodes and moving them. And I can map the remaining area as a farmland. So to map a farmland, I can select area. And if there is already some other land cover types, I need to attach the nodes. So usually in OSM, we keep attaching nodes only between features that are of the same class. So here I'm mapping land cover, and so I have to attach land cover classes to other land cover classes. Similarly, waterways with waterways, highways with highways, and I'm never attaching different features altogether, except from very specific cases. An interesting thing that I can do while I'm drawing a polygon that is attached to another one, the same goes with the lines. If I press F, I can select the nodes without moving my mouse. So I can just select and attach nodes with the same by just pressing one shortcut. So the farmland can cross rivers and roads because it's, let's say, the tag is referring to the general land use of the area. So all this area is used as a farmland. And is also much easier to maintain as data on OSM and also to modify later on if we need. So all this area is farmland. Why? Because I can see, as I was saying, all these crops, so all these regular shapes within the ground. So that means that the area is cropped by humans. Okay, I can see here another stream that is already mapped. This is mapped as a river, basically because the width is deemed, let's say, big enough not to be a canal or a stream. Um, that is okay, even because this river apparently also has a name, so we'll keep it like this. So I will just leave the feature like this, but this is definitely a natural feature because you can see the shape that is indeed digged by nature, no? Uh, okay, so now I still have to find something else to map in this task. One thing that I can see here is intermittent stream. I can see that there is also another line going until here. So you see also this one would be an intermittent stream because now I cannot see water, but in in rainy season for sure we will have water there. So we'll just map these. I will not attach the nodes between waterways and farmlands. And I can see the trace until here. Actually, I can expect to go until here, but I just leave it here. And I map the line as a stream. I need to say that this stream is intermittent. So to map the intermittency, I will just click here in the intermittent and it will say intermittent equals to yes. So the tag will be intermittent equal to yes, and we mean that this stream is not always present. If we want to reverse the flow of the river, in this case of the stream, we can right click on the border and press reverse or the shortcut V, so that you see the arrows are going from one side to the other and is flowing together with the other stream. So the important is to also, I mean, always care about the topology of the waterway network, so that we have all the features mapped in a correct way. Okay, now we have to chase other farmlands. Those are like all very rural farmlands, like spotting, I mean, here and there. So I will just map them as I can see them. So I can see this brownish area, and this for sure is a farmland. I'm just mapping as any other polygon that is like the easy part in this project. Also, this one, just giving you an idea on how you could map them, because many of those areas, I mean, they are much more difficult to understand from satellite imagery. So we can just map some cropped areas, and then you see the mapper on the task above will also map this small piece of farmland. So you can map them separately, like this, as I'm doing, or also with a big polygon like this one, enclosing many parts of the territory. That are both fine ways. I mean, we just here we just are mapping like farmlands that are a bit not very established. I mean, I think those farmlands are getting created during the switch between dry season and rainy season. And this area, I would say, is everything a farmland. So I can just add the polygons here. So I can, this time I will go to include a big portion of the area as they are all attached. And I usually finish a little bit outside my task, so that the close mapper to me, so those that are mapping on my right, they can download the data. So it's important to include all the, I mean, to map until the outside the borders. I mean, not much, but a little bit. Okay, here I'm mapping this farmland. You see, I'm little by little covering the area. I would say the other one would be this one. And actually, it's not an error if you are mapping a farmland and leave it unmapped on the border of your area. So now I will show you what I mean. So if we are mapping the farmland like this, so this area, I can map also a little bit of this. I can either continue this way inside, or maybe I can just map it as I can in this way. So, sorry. So if I don't finish if I don't have like clear borders of my farmland, but all this area is actually a farmland, I can leave it like this, and the next mapper would have to map another polygon adjacent to mine, so attaching the nodes. So in this case, if we map adjacent polygons, we won't have like any rendering problem, and also any computation problem because the area will have only one land use and land cover class by each. I mean, there won't be any overlapping polygons. So this is an approach also that we can follow. So this will be the farmland area on the northeast of my task. I can see here an intermittent stream that I would also map. So most of the waterways will be intermittent streams most of the times. And you see, like some of them are passing through, they are passing underwater. So you see, like the ground is not is a bit dark, and then sometimes they are sprouting up to the ground. So sometimes it's difficult to see and to understand what to map. I will, in this case, I can see one here. So this one, I will definitely map it, trim, then I reverse it as it goes to the agricultural to the farmland, and then I could even, I mean, this one is really borderline, but I will map one passing through this because I can see it from satellite imagery, and is going until here. This one for sure I will put it as an intermittent and flowing in the same direction. Because these areas for sure in rainy season will be flooded. So I know for sure that these areas are going to be full of water. Mm, and yes, and we have also this stream that is not connected with anything, unfortunately. Although we have one continuing here. So I think it's fine if you are finding this situation to map them without attaching to the overall waterway network because we cannot see where they start from. So we just map the waterway as we can see it. So it's going this direction. And then I stop once I go out of my task. So this is also an intermittent stream. And that's pretty much it. I would say everything has been mapped within this task. We are not mapping roads. We are only mapping agricultural waterways. We are not mapping villages. So everything that I needed to map is finished in this task. So I can submit my chain set. And I can choose another task. So I will have to, as usual, to put the status yes, it's completely mapped, submit the task, and I can switch to another one. I can see you are mapping um, in the project. Very good. Let me switch to the chat to see whether there are questions or comments. Do you have any question or comment so far? We still have 15 minutes. Ah, no, sorry, we still have 30 minutes. Okay, can you clarify in short about intermittent canal and how can the direction of the waterways be changed if mapped in the wrong direction? Okay, so we'll answer before to Mahesh Tapa. So once you trace the the waterway line, if you traced it in the wrong direction, you can just press V. Let me while selecting the waterway, and it will change the direction. So that is the shortcut by pressing the key V. Otherwise, you can go. Okay, let me just go back to one example. Going here. Okay, let's see. I was hoping to find, okay, this one, river. Okay, so let me trace, for example, I see. Yes, so you can you see let's say this is the line that I traced. You can right click on the line, and then you see you will see some buttons here, and if you go through them, there is one saying reverse, so you can make the line go to the opposite direction. So you click this one, and you will be coming back to the, you will reverse the waterway direction. So Gorak is asking, can you clarify in short about intermittent and canal? Okay, so intermittent waterways are those waterways that only have water passing through them during specific seasons. So when we are in dry season, like in this example, you can see we have a very, I mean, dry area. We don't have water or green a green landscape. We don't have grasslands, nor woods, nor shrubs, and so on. So once we are in a dry season, some of the waterways may not have water. So we have to map the water with a specific the waterway with a specific tag saying that it is not permanent, so it is intermittent. So let's say now I have to find an example because this area is not having many waterways. Okay, like this one is going that direction. Okay, perfect. So this one is a stream that is intermittent. Why? Because I can see the trace that is a natural trace in the ground, and I can see that the trace is having the ground color in the middle. So that is a completely dry stream. So I have to map it as intermittent. So I will just draw all the nodes of the stream. Oops. Until my box. I will click stream, and then I will click here in the intermittent tab. I will click on unknown, and it will become yes. So you can see here the tags. So the line is having two tags. So the first one is waterway equal to stream, and the other one is intermittent equal to yes. So this is the only the when I put intermittent. So when I cannot see the water flowing in the waterway. Uh, usually the only intermittent waterways are streams because rivers usually have water all year long, and canals and drains by design, let's say, they usually they have water because otherwise they won't be very useful. Regarding the canal, canals are mostly found. Okay, let me go to the area so that I can see and show one. So if we go to the Senegal River, canals are very are are wide, so you can easily spot them from the main river. So if you are editing the area close to the border, you will see canals very easily. While you cannot, I mean, maybe you won't find them in areas that are too far away from it. So you see canal. This one is a canal. So you see the river here. It's super wide. I mean, there is a whole village. I mean, this is by comparison the village and the river. But you can see here there are many farmland areas on the right. Let me enlarge. There are many farmland areas here on the east, and one big canal here. So this is like an artificial waterway because it's very, I mean, it has a very regular shape. It's built and digged by humans, so it's straight, going directly to the farmlands. So this is to be mapped as a canal. So you see the width is more or less, I mean, if we can check with the scale here, I would say the width is around 10 meters. So this will be mapped as canal, and you see is covering very well the full farmland area. So it's bringing water to the all the farmland. Then from canals, we are also having drains. So drains are much smaller, much narrower, and those are the drains. So like those in which you can see the trace, but you cannot clearly see the water inside. So the width will be around, I would say, 1 or 2 meters. So you can only see the line. So this will be mapped as drains, and they are usually connected to canals. So once, I mean, in the area in which we are mapping right now in the fourth project, this won't be like a usual situation. So you will see many drains that are not connected to canals at all. So we will see many streams and many rural farmlands, like farmlands that are not well established, like for example this one that I'm showing here in the example. I hope I was clear. So this one is a perfect, clear example of canal because you can see the width is around 10 meters or more and is passing through the farmlands. So this will be a canal and has to be connected with the river in some way. I hope it was clear. Um, uh, let me know if it was clear. Okay, superb, perfect. We have another question. As soon as I open your link, it appear a particular area map. If I wish map my area, what shall I do? Um, so you mean by using this link, we are yes contributing to the project in southern Mauritania, but you are wondering if you want to map any area, what you should do. So if you want to map any area, but not in this project, let me just submit the changes that I was doing. If you want to map on any area, you just go to OpenStreetMap. So here is where I live, but you can go to any area that you want. And then you connect your user to the OpenStreetMap.org website and you edit with ID editor. So you click on the arrow, you press edit with ID editor, and you see that you can map the area that you choose. So there is no pink box anywhere, so you can map all the area that you want uh, in your area. So usually we use the tasking manager to better coordinate between ourselves because between each other because you see like if we are mapping here and there if we are both mapping the same area in this way In case we are modifying the same object at the same time, we may have a concurrency problems. So the database will be not understanding which is the real version of an object. So this happens in OpenStreetMap. What we need to do is just later on to do the conflict resolution. So to decide which is the latest version of the object that we are going to submit to the database. So in order to avoid this very complicated problem, we just usually organize volunteers by tasks within projects. But if you want to contribute in your area as you want, you just log in OpenStreetMap and you edit from the ID editor here. Otherwise, with JOSM, you can download an area and you can map also in that case wherever you want. So the process is the same. The editor is just compiling the changes to the database and submitting to the database. So it doesn't, I mean, it doesn't block any area in OSM for you. I mean, everybody can map wherever they want, whenever they want. I hope it was. Let's take Nepal geography. Yes. So yes, you can go and map in Nepal with the IT editor. For this, I mean, for this collaboration with NGs, we were focusing our efforts in supporting FAO in southern Mauritania. So this is what we are currently focusing on. But later on, you can apply all the skills that you are learning from this training to also to apply them in your local area. So if it is Nepal, you can map there or you can map elsewhere. Okay, I hope it was clear. I don't know if you have any additional questions so far.
Mikhail, I have a question.
Otherwise, I can continue mapping for the last 15 minutes. I hope everything was fine. The recording will be made available in YouTube, so that you can follow through the different topics later on. Any other question so far?
Mikhail, I have a question. So I want to share my screen. Yeah. And
Okay, I will continue editing in another task. I can see many mappers are involved. So I have another question from Mahesh Tapa. Are swales waterlogged depressions also mapped as streams, or are they not included in this project? So those are mapped as intermittent streams if you can find them. Because in rainy seasons those are flowing all over the ground. So if you can see the swale, but you mean like stale water, like a pond? So if you mean like a pond which are not connected to a river, yes, you can map them. But they are not required. I mean, we are focusing mostly on agricultural waterways, streams, rivers, things that are visible. So if you are I mean, if you have a pond, I guess you can map it as natural water, and then you can put water equal to pond, or there are even others like water equal to lake. So those are tags that you can use, but the focus has to be on the agricultural waterways and the farmland areas. So those are the main features that we are editing. I mean, even natural rivers and streams are important because they are used for agricultural purposes, but in general, you are not required to map everything that you see. So the focus has to be on the agricultural waterways. Thank you. Okay, let's continue our mapping. Sometimes I just happen to check an area and everything is already well mapped. So in this case, we have the two farmlands that are already mapped and I mean, they are perfectly done. We do have wood here that is okay. And yes, we have like a little bit of wetland, but it's not important. So everything is fine. The Senegal River is here. We have a small water here, but we are already outside the task. So I will just say the task is completely mapped and I will submit it. Pawan, I see your hand is raised. I don't know if you have any question.
Oh, yeah, Mikhail, if you can hear me. Can you hear me?
I cannot hear you.
Okay. 1 second. I don't know if you can hear me. Yeah,
It's strange. I can see you in the transcription, but I cannot hear you myself.
Yeah. I don't know. Anyways,
It's very strange. I cannot hear you, but I can read the transcription. Maybe it's easier if you can just type in the chat.
sure.
Ah, no, the chat. Okay, you are. I don't understand if you are typing in the subtitles. This is something completely new in Teams. If you can go on the chat at the right, so on the right you should have like the chat of the meeting, and you have it's much faster. Let me share my screen. Here, if you go to chat meeting on the right, you need to click on chat, the chat button here. You can write it. Although you can write also here. Are you able to write in the chat? Okay, you can type in the chat your question, or if the microphone is not working. But here on the right, anyways, my question was: there is a pond kind of feature surrounded with dense trees in my area. Okay, so that will be either you can map it either as a natural water, so a polygon with a natural equal to water. So that will be the way we map polygons of water. Otherwise, if there is a lot of vegetation, usually we can map them as wetlands as well, because wetlands are grounds with water. And usually the distinction of wetlands is made by the vegetation that is present there. So maybe I can go very quickly on an example. I need to find one, and I guess okay, let me just open JOSM very quickly because it's easier for me to navigate the map and find similar situations.
My screen.
Just 1 minute that I'm opening JOSM. Okay. So let me find some areas. Okay, so there may be cases like this one in which you may want to map these water areas that are like this, but you see here we don't have any any vegetation on top of the water, so we can map this area as natural water. And if we want to be even more specific, we can add water equal to pond, or there are like many others, like basin in case it is an artificial water basin. We can map the beds of the canal, the ditches, the rivers, and so on. But in this case, I will map it as a pond. So this will be one way to map it. And I will map this way simply because I cannot see vegetation on this area. In this case, instead, you see there is there is uh, the ground that is very dark. So this is a wet ground, and so we mean that this is a wetland. And there are like different types of wetland. This one, for example, you can see like this greenery on top of the wet ground. This will be, I mean, this is like a wetland, and it's called marsh. So basically, whenever you have
Yeah, 1 second, Ma.
reed, so like very tall herbaceous vegetation, you will add natural, tag is natural equal to wetland, and another tag that we can use to further specify the wetland is wetland equal to marsh. So this means that the herbaceous vegetation is tall. So we have many reeds here within this area that is typically covered by water. So it's a wetland. Otherwise, if we do have areas like this one in which we have woods, so this is not reed like this one because you see the color is much brighter here. Here we have woods. So whenever we have a wetland that is covered by woods, like let's say this area, it could be, it's actually all the polygon, but it's just, I'm just cutting it here just to explain. This has to be mapped also with natural wetland, and the wetland in this case will be a swamp. So the swamp is a wetland in which there are trees inside it. So usually like a kind of a wood that is inside a wet ground area. So you can map, you can be very specific in OSM on mapping land cover. So in this case, I mapped a marsh, a swamp, or a pond in this case, because here we didn't have vegetation. Is it required for this project? No. So you can focus on mapping canal and farmlands or streams and rivers. and that's it. But I guess yeah, I answered your question. Thank you, Pawan. Okay, so we are around the end of the meeting. So if you have any further question, otherwise I can close. And just before closing, I want to mention that we are going to have like on the 29th of August MAPI hour. So we are going to map with the community, and you are invited to do a presentation of NGs if you want, 5 minutes, so that we can speak about this collaboration. And we invite you also to join the MAPI hour on the 29th to map all together. Thank you, Gorak, for having me. It was a pleasure. And we will be staying in touch to share the recording later on YouTube, so that you can access the training even later. But I hope it was clear. I went through. I mean, it's not like a very easy topic, the one of agricultural waterways, but at least I showed the main tags and the main topology features that we have to take care of when mapping these areas. Okay, thank you. I don't know if you want to take a picture before ending the meeting, because I know Arnali loves loves to share pictures on the social media. I can see
Yeah,
Pawan,
everyone. Yeah,
the
let's.
the only one turning on the camera. Gorak is coming as well. Mahesh Tapa, Prince Kumar Singh. Don't be shy.
Let's take picture, guys.
Vivek Dumre, another one. Okay, so Ramesh Oli. Okay, so slowly they are coming. Okay, so let me take a screenshot in 3, 2, 1. Wait, I was missing Govind. 3, 2, 1. Okay, thank you very much. I don't know, Gorak, if you want to have like any closing words for the session.
Am I audible? Hello. Okay. So thank you so much for this wonderful presentation. Like it's been since many years, but hadn't had this kind of deep knowledge about water bodies and how can you distinguish it. But for the closing remarks from our Nepal Geomatics Engineering Society, I would like our president, Mr. Mahesh Thapa, to conclude this training and thank Mikhail for this wonderful presentation. Thank you. Over to you, Mahesh Thapaji.
Thank you, Gorak. I just want to ensure I'm audible.
Yeah, sure.
Okay. First of all, I would like to thank Gorak and Vivek and Samrat for taking the initiative to conduct this training program. As we all belong to geospatial domain, and we know the importance of data and how scarce the data is really to get. and we also know how useful this spatial data are. And in many situations, like the earthquake in 2015, the data means difference between life and death. So I think it's really important. A lot of international community, they have helped Nepal by conducting mapping works voluntarily. And I think through this program, we want to reciprocate the help that we got internationally, and to help others also by mapping. So thank you, Mikkel, for this wonderful training. I think the reason that you were showing and the task is definitely not easy. It's a bit technical, but I think with a little patience, it can be done. It's something like a detective work, I see, finding the streams and then finding the agricultural areas. Maybe it's the difference in the terrain between Nepal and Mauritius. It may be the reason, but I think with patience, it can be done. And I'd also like to thank all the participants for being in this program. I hope you stay motivated and help us finish this work. But in the future, we will also try to collaborate with UN mappers again, and also do mapping in context of Nepal also. So thank you. And by this, I'd like to end the session.
Thank you very much, Mahesh, for the kind words, and I hope we will have also other collaborations in the future. And also, yes, what you say is true. Like we are doing a project in Southern Mauritania, supporting the Food and Agricultural Organization of the UN. But all these skills and OpenStreetMap in general is available to everybody everywhere. So all the skills that you are gaining here, or the practice that you will gain in this project, can be applied also in Nepal for further projects. So thank you very much for attending, and I wish you a nice day. Thank you for hosting me. Bye.
Thank you. Bye bye.